Connect to live.
Okay, sir. Okay. Okay.
Color pencil.
Okay.
Now,
Okay. On this side.
front one color, back side one color.
Okay. Thank you, sir. Fine. Good evening, everyone. How are you all? Happy? Yeah. So keep your mind and soul fresh, right? So what we have discussed in the previous class? Tangents and secants. Tangent is the one which touches the circle at 2 points, right? Which one? What is the tangent? Tangent is a line which touches the circle at 1 point. Are you 10? Are you 10? What is the tangent? Tangent is a line which touches the circle at a 1 point. Okay, and what is the secant? At a 2 distant points on a circle. That is a secant. Okay. Next, we had discussed about tangent. What is the point of contact? Yes. What is the point of contact? The point where the tangent touches the circle, that point is called point of contact. And what is the chord? The line segment, the joining of line segment of a circle, two lines joining of 2 points on a circle, that becomes a chord. Okay, the area subtended by a chord. 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 It may be a minor segment, may be a major segment. Okay, right? Both, but it is called a segment. Okay, what is the sector? Okay, sector. This is what we call sector. Okay, so all these points, key points we have discussed, and we have even finished 9.1 exercise. Now let us understand number of tangents to a circle from any point. Number of tangents to a circle at a from any point. From any point. Yes, let us do one activity. Take 3 circles. Okay. Fine. I am taking a point here. From this point, how many tangents you can draw? Yes. From this point, how many? Try to draw a tangent. A line, this line, any number of lines you draw from that point. Can you find any tangent here? Yes, no. All these are what we can say? Secants. Okay. So there is no tangent here. Fine. Now we consider a point on the circle. On the circle. Draw tangent on this. Yes. Can you draw one more tangent? No. Try to draw one more tangent like this from this point. Can you? No. So at maximum, how many tangents we can draw from a single point? Answer. That last person. You are ninth. Okay. So how many tangents we can draw? One tangent. Okay. Let's take a point here outside the circle. Okay. How many tangents you can draw from that outside the point? 0, 2, 1. Okay. Check it here. From this point, yes, one line. From the same point, yes, one more, try. Can you? No? Nothing. Okay, let's take from here on. No? So how many tangents you can able to draw? Only 2 tangents. So from an external point, how many tangents we can draw? 2. Here, here 2, here 1, here 0. A point on the circle, we can draw only 1 tangent. How many tangents? 1 tangent. A point from external of the circle, exterior of the circle, we can draw a maximum of how many tangents? 2 tangents. Okay. Is that clear? This is the activity that you can find from your textbook. Fine. From here, what we can say, there is a no tangent for a circle from interior point. From inside of a point, from inside of a circle, if you choose any point, from that point we can't draw any tangents. Okay. A point on the circle, we can draw how many tangents at maximum? 1. And a point on the exterior or outside the circle, how many tangents we can draw? 2 tangents. Okay. Next, theorem 9.2. If you have a textbook, you can refer. Theorem 9.2. The length of tangents drawn from an external point to a circle are equal. Okay. The length of tangents drawn from an external point to a circle are equal. Okay. Let me clear one small thing. Length of the tangent. Length of Anybody getting any doubt? I am getting a doubt. Can anybody solve it? Yes. My doubt is, as we are saying a line passing through a point on the circle, that is a tangent. How can you find the length of a no end point line? As a line do not have any endpoints. How can you measure the length of line? Common point. Okay. Yes, fine. Two lines meeting at common point. Okay. And from where we are finding? Up to the circle. This is the circle and it is the point. From which point to which point? One is the exterior point where it is the starting from. Okay, that is the main thing you need to understand. So the length of the tangent is the length of the line segment. Length of a line segment of the tangent from external point to the point of contact, to the point of contact. Am I clear? This is the length. Okay, line segment. You can note it down. Next, theorem 9.2, the lengths of the tangents. Okay.
Sometimes the answer will come.
Okay, sir.
The answer will be there.
Okay, sir. I'll take it. Okay. Right. Thank you. Okay. Is that clear? Is that statement clear? Fine. Next, theorem 9.2. The length of the tangents drawn from an external point to the circle are equal. Okay. Let us consider one circle. Okay. And that is, tell me, not written, make it fast. The length of line segment of the tangent from external point to the point of contact. Okay. If my handwriting is like a doctor handwriting, you need to understand, you need to become medical of shop. Okay, medical shop person who will be there, only those people who can understand the doctor handwriting. Yes, Jiaguda branch people, are you following?
You should contact with them, sir.
Yes, sir, that's what I was asking.
Like if you speak, their sound won't come, sir, in this system.
Okay, sir.
But they can respond you by raising hand.
Okay, sir.
This,
That's what I was checking.
yeah. This group is another one, sir. They are also 10th.
Okay.
This is another group.
Okay.
They are slow learners, sir. So right now they are listening another class.
Okay, right, sir.
So this is our present class, sir.
Okay,
In this hall.
Okay, sir.
These are present, sir.
Fine, fine.
So whatever you are teaching here, they are listening there, sir. At
Fine,
the same time.
fine, sir.
Okay, sir.
That's what.
Yeah, Jagoda branch. Now onwards, master will also communicate through the video. Right, you should respond by raising hand accordingly. Okay, everyone. Okay, sir.
Okay.
And
Okay, sir. Fine. Yes. This is an external point. These are the two tangents. Let the external point be P, and this is the center O, and this is point A, point of contact B. Two point of contacts A and B. Okay, and we know that the angle between radius and tangent is how much? 90 degrees. What is the symbol of this one? 90 degrees. Okay, right. And we need to prove that PA is equal to RTP. RTP means right to prove or required to prove. What? Required to prove. So the length of the tangents are equal. PA is equal to what? PB. PA is equal to PB. Fine. Now what we do is we'll join this point P and O. P and O. We join this point P and O. Right? And consider triangle PAO. Triangle PAO and triangle PBO. PBO. If you respond, I'll get more energy. Yes? PAO, PAO and PBO, these are the two triangles. Okay. Angle A is equal to what? 90 degrees. And angle B is equal to, both are same? Yes. So what I can say? Angle A is equal to angle B, since they are 90 degrees. Next, and AO is equal to BO or OA OB, like that also we can say. Okay, since what it is? Radius are equal. Yes. Next, and what more? PO or OP. OP is equal to OP. What is this? Common side. What is that? Common side. Do you know RHS? What do you mean by RHS? Right hand side, right? But in a congruency of RHS is not right hand side. Okay. Congruency of RHS is not right hand side. It is what? In a two right angle triangle, if you consider two right angle triangles, if the corresponding hypotenuse are equal and one of the sides is also equal. Then right angle, hypotenuse and one side. Right angle, hypotenuse, side. The corresponding, the right angle, hypotenuse, side of a triangle are equal to right angle, hypotenuse and side of corresponding sides of another triangle are equal, then the two triangles are congruent. Congruent. Similar is different, congruent different. Similar means your photo and you are similar. Okay, your photo and you are similar. Okay, you in front of mirror both are congruent. Understood? In a plane, in front of plane mirror. Am I clear? It means both are in all aspects, this both are equal. Then what we can say by RHS congruency, by RHS congruency, by RHS congruence, triangle PAO is congruent. This is the symbol to triangle PBO by CPCT. Do you know what do you mean by CPCT? By CPCT is corresponding parts of congruent triangle. All the corresponding sides and angles are equal. So PA is equal to what is this PA and PB? What are this PA and PB? Tangents. Therefore, the two tangents, drawn from an external point are equal. Okay, 1 minute enough? 1 minute enough for writing? Yes, time count started. The screen will be on for only 1 minute. The next slide will open in 1 minute. Jiyaguda branch, backside people, everybody are not writing, only some are writing. Are you writing? Yes. Over. Next. Next, construction. Construction of tangent to a circle. Construction of tangent to a circle from an external point. Construction is different, drawing is different. Okay. Do you have compass? Yes, open the compass, scale, pencil. We learn by doing. Learn by doing. Draw a circle of any radius. 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 And consider a point outside the circle. It is a point. Yes, did you draw? Draw a small circle. If possible, draw a small circle. Jayaguda branch students also draw. I am watching you. Draw a small circle of any radius. Let's say 2 centimeter radius. Draw a circle of any radius. Yes, drawn. Yes, 1, 2. Yes. You know. Drawn. Yes. Fine. Okay. Now, join the point, external point. Join this external point with the center. Join this external point with the center. Join this external point with the center. Let the external point be P. Center is the O. Drawn. Next, you need to construct a perpendicular bisector for OP. How do you construct perpendicular bisector to this line OP? More than half. So take your compass, measure the length more than half of this OP. More than half. Okay, more than half approximately. And make one arc above, one arc below. Make one arc above and one arc below. With the same length, P as the center, draw one arc above, one arc below. First what? O as the center, take more than half of OP on compass. Mark one arc above the OP and one arc below the OP. Then P as the center, one arc above the OP, one arc below the OP. to cut the previous arcs. Okay. Now join these 2 points. Join these 2 points. Join these 2 points. Join these 2 points. This is the perpendicular bisector of OP. Perpendicular bisectors of OP. Now OP, the line OP is equally divided into 2 halves. Not divided. So it will come by the scale perfectly. Okay. Fine. Now it is a perpendicular bisector. Draw a circle. Draw a circle with the radius. Let this point be M. This point is what? M. Here PM is equal to OM. PM is equal to OM. So draw a circle. Okay. OM as the radius and M as the center. Draw one circle. Draw one circle by using compass. Okay. Now this circle is intersecting the previous circle at 2 different points. Let the points be A and B. A and B. Now join PA and PB. PA and PB. Sorry, right. Join P to A P to A and P to B. PA and PB. Join PA and PB. These are the two lengths of the tangent. Okay. The only task is to find these points. The major task is what? To find this point. The point of contacts we need to find. To find those point of contact, we are doing all these constructions. Okay, fine. Yes, everybody did. Yeah, good. Okay. Actually, this drawing has not done perfectly. Okay. But with the construction, it will be the best diagram. Yes, very good. Jayaguda branch. Show me the construction to the camera. Show your construction to the camera. Okay. Fine. So from here, yes, ma, done. Everybody done. Next. 9 point. Sorry, this is the theorem. 9.2 over and construction of tangents to a circle. Hope you have understood. Yes. Next, four statement. Four statements we learn. First statement is the center of a circle lies on the bisector of the angle between the two tangents drawn from a point outside it. Can you think how can we prove it? The center the center of a circle the center of a circle lies on the bisector of angle between the two tangents. Angle between the two tangents. B by W means bed. Okay. Two tangents drawn from an external point. External point. The center of a circle lies on the bisector of angle between the two tangents drawn from an external point. Okay. The diagram will be this angle, this is the angular bisector, this is the point O, center of the circle O. This line PO is the angular bisector. PO is what? Angular bisector. PO is the angular bisector. Angular bisecting means the angle BPA, the angle, or APB, the angle APB is divided into two equal halves by the line PO, but by the line PO. So this angle, if it is total angle is the theta, then this one will be theta by 2 and this one will be theta by 2. Okay. How can we prove it? Okay, let's do the proof. What is the RTP? RTP. RTP. O point O lies on OP, lies on a OP. Point O is what? Center of the circle, lies on a OP. Okay. Consider triangle PAO, PAO and triangle PBO, PBO. Angle A is equal to angle B. Yes. Why? Since 90 degrees. Since right angle between radius and tangent. Okay. And AO or OA is equal to OB. OA of triangle PAO, OB of triangle PBO, both are equal. And PO, why these are equal? Since they are radius. They are radius. They are radius. And PO is equal to PO. PO is equal to OP, we can say, but since what is this? Common side. Common side. So by RHS, by right angle hypotenuse side congruency, triangle PAO is congruent to triangle PBO. Therefore, by CPCT, all the corresponding parts are equal. Now, PO is the common side, right? PO is the common side and passing through what? Through O, center. Yes, PO is, so O lies on a angular bisector of tangents, the two tangents where they form an angle. So PO or OP is the bisector of angle QPR. Here one more thing we can write. APO, angle APO. Okay, angle APO. Check it here. Angle APO is equal to angle BPO by CPCT. Angle APO is equal to angle BPO. Both angles are equal. Both angles are equal, theta by 2, theta by 2. Okay. So this, therefore, PO is angular bisector. Therefore, O. Therefore, center O lies on PO. Lies on PO. Okay, you can write. Yes, finished? Everybody. Next, statement 2. Next. Statement 2. What is the statement 2 is? Do you know the meaning of concentric circles? You know. Yes. Two circles with the same center two circles with the same center, two circles having same center with a different radius, with a different radius. It is small r and big R. Two centers having same radius is called, two circles with the same radius, two circles with the same center but different radius. Two circles with the same center but different radius. Okay, these are called concentric circles. Okay, what is the statement given? In two concentric circles, the chord of the bigger circle that touches the smaller circle is bisected at the point of common point of contact with the smaller circle. Yes. Let us take one chord which touches the smaller circle at a point P, and the radius of the small circle touches at point P. The chord is AB. The chord is AB to the larger circle, and point P is the point of contact to the smaller circle. Okay. Now, the point of contact divides AB into two equal parts. That means RTP is what? AP is equal to PB. AP is equal to PB. Otherwise, we will write like this. AP is equal to BP. AP is equal to what? BP. How do you prove it? Join what? Join OA and OB. Join OA and OB. This is the center O, OA and OB, and this is a angle 90 degrees. The line touches at only one point. What is that line we call? Tangent. So AB is the tangent to the smaller circle. AB is what? A tangent to smaller circle. Therefore, AB is a tangent to smaller circle. Therefore, OP is perpendicular to AB. OP is perpendicular to AB. And consider triangle AOP. Triangle AOP and triangle BOP. Are you following? Triangle AOP and triangle BOP. Okay. OA is equal to OB. OA is equal to OB. Why? These are larger triangle, larger circle radius. Larger circle radius. And OP is equal to what? OP. Since what is this? Common side. Common side. Okay, common is only one side, not sides. Okay, and angle APO or OPA is equal to angle BPO, since that is equal to what? 90 degrees. Since OP is perpendicular to AB. Okay. Equal to 90 degrees, since OP is perpendicular to AB. Okay. Next, sides C. AO is what? OA is what? Radius. This is the right angle triangle. These two are what? Right angle triangle. hypotenuse are equal and one side is equal and one angle is that is equal to 90 degrees. By which congruency? By RHS congruency. By RH congruency, triangle AOP is congruent to triangle BOP. Okay, therefore by CPCT what are equal? The corresponding parts of congruent triangles are equal. Therefore AP is equal to BP. AP is equal to BP. Okay, this is the statement 2 proof. If not understood, I will explain again. Understood? Everybody? Two more statements are there. Do you want statement proof or only statements? Huh? Yes? Only statements enough? Okay. The next two, three and 4 statements, we'll write the statements only. Fine? Yes. Next. Statement 3. Statement 3. What is the statement 3? if two tangents AP and AQ are drawn to to a circle with center O from an external point A, then angle QAP is equal to 2 times of angle QPO, that is equal to 2 times of angle OPQ, sorry, OQP. To a circle, a point A from an external point A, two tangents are drawn, from this external point A. This is the center O. To the 2 points P and Q. This is the theta, angle theta at external point. Okay. AP and AQ are equal. In a simple way, I will tell you to understand this one. This angle, okay. Stop writing, everybody, and look at the board. Look at the screen, everyone. Look at the screen, everybody. Theorem I am not giving you to write. Just understand this. Consider triangle APQ. We know that two tangents are equal. As these two tangents are equal, the angles opposite to equal sides are also equal. These two angles are equal. Am I clear? In a triangle APQ, as these two tangents are equal, the angles opposite to the equal sides are also equal. Okay. Now consider triangle OPQ. These are the two radii, two equal sides. So the angle formed to the opposite sides, to the opposite equal sides, are also equal. These two angles are equal. Am I clear? The angle between radius and tangent is a 90 degrees. Yes, this is 90 degrees. Fine. But this 90 degrees is divided into two parts. One is the larger part, one is the smaller part. Okay. Right. At this angle, this part is removed. This part is removed. So this will be less than 90 degrees. This will be less than 90 degrees. Okay. Sum of the angles in a triangle is equal to 180 degrees. Right. So this angle plus this angle plus this angle, these three angles are equal to 180 degrees. Yes. By using these conditions, we can prove that this angle theta is equal to angle PAQ, angle PAQ or QAP. Okay. Angle QAP is equal to, angle QAP is equal to 2 times of PQO, 2 times of angle PQO, or that is equal to 2 times of angle QPO. Listen carefully, QPO. That is the statement number 3. Statement 3. Okay. this angle is equal to 2 times of this angle. Okay, and this angle is equal to 2 times of which angle? This is x, then this also x. Okay, so theta is equal to, simply theta is equal to 2x. Theta is equal to what? 2x. Okay, right. Next, statement number 4. Statement number 4. Statement 4. If a quadrilateral ABCD is drawn to circumscribe a circle, means a circle is drawn. A circle is drawn and it is circumscribed by a quadrilateral. Okay. Okay, this is the quadrilateral A, B, C, D. Okay, understood? Otherwise, let me do it one thing. Okay, this is one external point A, B, C, D. Okay, the line AB is intersecting the circle at point P, at a P, and BC is intersecting the line at point Q, and CD at R, and AD at S. Okay, 2 minutes will finish it off. Okay, so here AB is equal to AB plus if a quadrilateral ABCD is drawn to circumscribe a circle, then AB plus CD is equal to BC plus DE. AB plus CD, opposite sides, sum of the opposite sides of the quadrilateral is equal to, are equal, AD plus BC. Okay, AB plus CD is equal to AD plus BC. Okay, this you better remember. Okay, these are the 4 statements. Just recall before coming to the class for the next, okay, for the next class. Fine, we are going to solve the problems. I'll be asking you in the middle of the problems. You must answer these questions. Okay, all these 4 statements you must remember. Fine, thank you. Any doubts? No doubts? Thank you. Sir.